You know, every so often, a story comes along in the tech world that is just so wild, you can't ignore it. Right now, that story is all about a company out of Finland called Donut Lab. They claim to have a battery that does, well, pretty much everything you could ever dream of. If they're right, it changes the world. If they're wrong, it's a huge controversy. So let's try and figure out what's really going on. Okay, wow. You just don't hear a CEO from a major company talk like that about a competitor. It is blunt, it is brutal, and it really sets the stage for just how skeptical the experts are. This one quote just cuts right to the heart of the debate. Is Donut Lab onto something incredible? Or is this whole thing just smoke and mirrors?
And to understand that skepticism, just look at this list of claims. I mean, honestly, just one of these would be a game changer. 400 watt-hours per kilogram, that's amazing energy density. 100,000 charge cycles. For most of us, that's basically an eternal battery. But to have all of this plus a 5-minute charge time and no lithium or cobalt, it stops sounding like engineering and starts sounding like a magic wand.
So, to figure out why these claims are raising so many red flags, we have to pull back the curtain a little bit and look at the fundamental rules that all batteries have to play by. It really comes down to what's physically possible.
Think of it this way. It's like building a car. You can make it super fast, but it's probably not going to be very fuel efficient. Or you can make it incredibly safe, but it might not be the most agile. You can't have it all. Battery chemistry is exactly the same. Every single decision you make is a compromise. And this right here is the biggest trade-off of all. If you want to cram a ton of energy into a small space that's high energy density, you have to use materials that are thin, lightweight, and frankly a bit fragile. They wear out fast. But if you want a battery that lasts forever, high cycle life, you need the literal opposite: thick, robust, super stable materials. Donut Lab is claiming they've somehow squared this circle, solving a problem that the best minds in battery science have been stuck on for decades.
Okay, so if the claims seem to fly in the face of physics, what about the actual data? Let's put on our detective hats for a minute, because some third-party test data has been released and it gives us some serious clues.
And our biggest clue is something called the electrochemical fingerprint. It's a fantastic concept. See, every battery chemistry has a unique signature in its voltage as it charges and discharges. By looking at that voltage curve, you can tell what's inside the battery without ever cracking it open. It's like a chemical fingerprint.
And this is where it gets really interesting. When you plot the test data from the Donut Lab cell, well, it looks exactly like a high-performance lithium-ion NMC battery. A dead ringer. For instance, its resting voltage is around 3.75 volts. That is way too high for a sodium-ion battery, but it's right in the sweet spot for a lithium-ion.
So, you're thinking, aha, case closed. It's a lithium-ion battery after all, right? Well, not so fast, because the moment you accept that, the rest of their story completely unravels.
And this is the core of the mystery. The fingerprint screams lithium-ion, but the company insists there is zero lithium inside. The energy density is possible for a next-gen lithium-ion cell, but impossible for sodium-ion. And that 100,000 cycle claim? That's not possible for any known commercial battery. Nothing adds up.
All right, so if we can all agree that the official story has some major holes, then what are we actually looking at? Well, a couple of major theories have popped up to try and explain it.
The first big idea is, what if it isn't really a battery at all? What if it's some kind of high-tech supercapacitor disguised as a battery? This would instantly explain that insane cycle life number. See, a battery uses chemistry to store energy, but a supercapacitor does it with physics.
It's more like storing static electricity. Because of that, they can charge super fast and last for, you guessed it, hundreds of thousands of cycles. It ticks two of the miracle boxes perfectly. But, and this is a huge but, they are terrible at storing a lot of energy. They can't even get close to that 400 watt-hour per kilogram claim. And to really put this theory to bed, the company's CEO came out and shot it down directly. He said, and I'm quoting, "This is a fully solid electrolyte battery. There are no gimmicks or euphemisms used here." So, we have to keep digging.
Which brings us to the second and maybe more compelling theory. What if the battery they tested is a real, high-tech cell that they just bought from someone else? What if it's a rebadged product with their own unbelievable claims sprinkled on top?
Now check this out. When you compare the Donut Lab test data to a known solid-state battery from a company called Palladium, the similarities are striking. The energy density, the fast charging, the thermal stability, they all line up. There's even a very specific technical quirk called voltage hysteresis, which is a known telltale sign of a silicon anode. And guess what? Both batteries have it. It's a pretty compelling match. But just when you think you've cracked the case, you run straight into two massive brick walls. Palladium's battery is rated for about 1,200 cycles, not 100,000. And of course, Palladium's battery is full of lithium. This theory explains the test data we've seen, but it can't explain the two biggest, most revolutionary claims.
So, after going down the rabbit hole with the science, the data, and the theories, where are we? Honestly, we're right back in the thick of it, trying to solve a genuine battery mystery.
Here's the bottom line. The physical, testable evidence, that electrochemical fingerprint, points directly at a known type of advanced lithium-ion battery. But the company's biggest claims, the ones that make it a miracle, are completely unproven and seem to break the laws of physics. And when you throw in the company's murky relationship with another entity called Nordic Nano, the plot just keeps getting thicker.
And maybe this is a clue. This line from a leaked letter to investors promises, well, an absolutely insane return on investment. That kind of promise suggests a very powerful motivation to generate as much hype as possible, even if the science doesn't quite back it up.
So in the end, that's the big question, isn't it? Are we looking at the greatest energy breakthrough in a generation, or are we looking at a brilliant marketing campaign designed to pull in investment? Right now, the public data just doesn't add up, leaving the rest of us to watch and to wonder what the truth really is.